Whoa. Okay, so how many atoms of oxygen are in aluminum sulfite? You need the formula for aluminum sulfite to do that. Aluminum is 3+, sulfite is SO3, 2-. What would the formula be? SO3, 3. Okay. Al2, SO3, 3. And so when it asks how many oxygen atoms there are, what you would need to do is you would need to say, I have a 3 here on the outside of the bracket, but I also have a 3 on the inside of the bracket. So I need to say I have 3 times 3 gives me how many? 9. It's supposed to be a 9. Looks crazy. Try again. 9 O atoms. What if I asked you how many total atoms are there in this same compound? Tell your partner, how many total atoms are there in Al2, SO3, 3? Okay, we have 2 aluminum, so that's 2 plus 3 sulfur. So 2 plus 3 is 5, and 5 plus the 9 oxygen gives us 14. So if you are a person who did not get this done, this will be part of your weekend homework. I think most of you have it done already, okay? Now we're going to move on to page 14, and we're going to be looking at converting atoms and molecules. And when we convert between atoms and molecules, we use what we call the particle ratio. And the yellow sheet that you got today, I'm sorry, it is such a violent color. What we're going to be using from there today is, we're going to just take a look here. And if any of you would just like a blank white copy instead of the yellow, just let me know. I can get you one that's not quite so, dreadful. See our particle ratio here? That allows us to convert from particles of A to particles of B. So particles of one substance to particles of another substance. So that's what we're going to be focused on today, is this conversion on that page. Eventually, we're going to do all the conversions. Yeah? But for today, we're just going to focus on that one. So basically, this requires you to be able to count atoms in molecules. So how many oxygen are in one molecule of carbon dioxide? Straightforward. How many? 2. And if we write this as a conversion factor, we can say there are 2 O atoms. And that division line there means per 1 CO2, and we've been using MC for molecule, yes? Have we? Okay, MC is molecule, just in case. So now, how many atoms of oxygen are in 3 molecules of CO2?
6.
There are 6, and it's really easy. You can go 1, 2, 3, 4, 5, 6, but most questions will not be this easy, okay? So if we wanted to show this using conversion factors, we would go to our question. Gian, could you close the door for us, please? Thank you so much. So our initial quantity in our question is 3 molecules of CO2. Okay, so that's our initial. And then we need to multiply by a conversion factor. What needs to go on the bottom so that it will cancel? Molecules of CO2. And you don't have to write the of, you can just write molecules CO2. It's also fine. You can write CO2 molecules. It's the same thing. Yes? Doesn't matter which way around. So for every 1 CO2 molecule, we have 2 oxygen atoms. And we get our molecules of CO2 cancel out, and we end up with 6 O atoms. So this is just about showing the work, and I know it's super easy right now. This will be one step in a multi-step problem very, very shortly. So get used to doing this part, okay? And this right here, this conversion factor, that is the particle ratio. Now we're going to get a little crazier. Crazy! How many CO2 molecules could you make if you were given 8 oxygen atoms? 1, 2, 3, 4, 5, 6, 7, 8 oxygen atoms. How many CO2s could you make? You could make 4 because you could put a C here and a C here and a C here and a C here. Why does it do that little thing only sometimes? It's so weird. But anyway, that's okay. Right? We can make 4 CO2 molecules. How would we show this using conversion factors? We would say we want to find the number of CO2 molecules. That's our unknown. What is our initial quantity? 8 oxygen atoms. And I like to put a big space between whatever the number is and O atoms, because otherwise it looks like 80 atoms. Yes, so you'll notice I put a huge space there. And you might also notice that the O atoms kind of looks like Odoms, which sounds like a breakfast cereal. Nobody like that? Okay, that's fine. I think it's cute, but so now we have, I don't know why I underlined that because we're not doing that. What am I doing? Now we need to multiply by a conversion factor. Who should go on the bottom of our conversion factor? O atoms. And what should go on the top? CO2 molecules. And just like any other conversion factor, you know, we had 2 over 1. Now we have 1 CO2 over 2. You can flip it upside down. And what do we call this conversion factor here? That's called the particle ratio. So we get 4 CO2 molecules. How do you find a particle ratio? Like if I give you the formula CO2 and I say, what's the ratio between O atoms and CO2 molecules?
2:1.
All you have to do is look at it and count, yes? So if you did okay on counting the various atoms, you'll be good with finding the particle ratio, yeah? Okay, here we have methane. So let's write a few conversion factors, a few particle ratios. So between molecules of CH4 and atoms of H. Do you guys think you could do them on your own? Yeah? Try it. Now, I think the first two are pretty straightforward. What about that last one? 1 atom of carbon per 4 atoms of hydrogen. And it's okay if you write H atoms instead of atoms H. Either way is fine, okay? Or, of course, you could have 4H over 1 carbon. And it's okay to write it this way as well, leaving out the atoms and the molecules, because it's pretty straightforward what you mean by that, okay? Could you use these conversion factors to solve these problems? Do you want to try it on your own? Or do you want me to show you? Try it? Try it. So if you're stuck, remember, you'll want your unknown is equal to your initial, and then you'll multiply by one of the conversion factors. Okay, we got all kinds of things going on. You guys have forgotten, some of you, how to show your work with conversion factors. That's okay. It's been a while. We haven't done them in a while. So let's make sure that we review this. So we have our unknown, which is carbon atoms. So we're going to say, I don't know how many carbon atoms. Okay, so that's your unknown. How many carbon atoms is equal to our initial quantity, which in this case is the CH4 molecules. Okay, 128 CH4 molecules. And then we need to multiply by our conversion factor. And remember, the conversion factor, you always draw a line. And then you put whatever you want to cancel wherever it needs to go, what needs to cancel out? CH4 molecules need to cancel out. So we're going to put it down here, CH4 molecules. And we're going to put what we want to find on the top. What do we want to find? Carbon atoms. Okay, and then we can go and say, how many carbon atoms were there per CH4 molecule? Well, there was 1 carbon atom per 1 CH4 molecule. CH4 molecules cancel out, and we get 128 carbon atoms. By the way, if conversion factors are your thing, if you're like, I am a conversion factor expert, I do not need this review, Ms. Spence, you feel free to just go ahead and do 5.1e and 5.1f, and you could even do 5.1g, right? You don't need to wait for me if you're finding this super easy. But I do want to do this review because for some people it's like, whoops, conversion factors, it's been a few weeks. I need a little review. Okay, so once again, in B, we want to discover who is our unknown. We look for our question word. How many? Right? That's our unknown. And how many is how many hydrogen atoms? So our unknown is the H atoms. Okay. Our initial is what is given in the question. Okay, and we're given 128 CH4 molecules, 128 CH4 molecules. And don't forget, we want our unknown is equal to our initial times our conversion factor. So you're going to write down your unknown, which is I don't know how many H atoms. And then equals your initial quantity, 128 CH4 molecules times your conversion factor. So you draw your line, and your unit up here is going to go down at the bottom. So CH4 molecules. Okay, those will cancel out. And we want on the top, we are solving for hydrogen atoms, so we want hydrogen atoms on the top. And we figured out, we looked at CH4. There's 4 hydrogen atoms in 1 CH4 molecule. 128 times 4 is 512 H atoms. Is good? Okay. Do you want to try the next one on your own? If you haven't already? Give it a go. Try the next one. Write it out exactly the way I've shown you. Unknown equals initial times conversion factor. Okay, sorry. I was having trouble reading it upside down. Is this okay? Am I giving credit for this? No. I'm giving you 0 credit for that, right? Okay, yeah. But you would be able to write a word? Yeah. Okay. You need to show your work like that. Because pretty soon you're going to follow the chain. This is one step of a multi-step problem. So this is not. Okay, the unknown is equal to initial times your vertical. Okay, simplify this. That is one way of doing it, and it's perfectly good. This and just multiply by 1 carbon atom over 4 H atoms, because that's another ratio as well. But yes, you can. I don't know how to make this any clearer. If you are not showing your work using conversion factors, you will not get credit. And the reason is that conversion factors are the only efficient way to show your work when we start putting more than one step together, okay? Here we're just one step. It's easy to do it in your head. Lots of people could do this in your head. But you'll come to questions where, let's go look. You can go, where the heck was it? You will be going from volume via density, via molar mass, via Avogadro's number to particles of B. You'll have a 4-step problem. And you'll want to be able to chain those all in a line. And if you're not using conversion factors, you cannot chain them. Okay? To be honest, this is more about learning the process than it is about like the specific conversion factors, although it is about that as well, okay? All right, so let's check our answers here. How many molecules of CH4 can we make, write the equal sign, from 128 hydrogen atoms? Hydrogen atoms have to go on the bottom. Molecules of CH4 have to go on the top because that's what we want to find. Hydrogen atoms cancel out, and we have 1 for every 4. Does that give us 32? Good. 32 CH4 molecules. And don't forget, you need your unit at the end. If you have 128 H atoms, how many carbon atoms? I guess I should start with how many carbon atoms can we make from 128 H atoms? Yes, of course you can. So we need to cancel hydrogen atoms, so H atoms go on the bottom. We want to find carbon atoms. Carbon atoms go on the top. So now we look at our formula, CH4. There is 1 carbon for every 4 hydrogen. Okay, and again, we get 32 carbon atoms. The hydrogen atoms cancel out, and we are left with the unit carbon atoms. Is good? Okay, that's it for that one. We're going to move on to formula units and ions. There's not much difference here. It's the same math. It's just that we have to write charges on our ions, and polyatomic ions we keep together as a little group. Okay? So this is on page 16. So let's remember a formula unit is kind of like a molecule, but it's for an ionic compound. So if this is our ionic compound, it's in the form of a crystal lattice, and a single unit of that crystal lattice is a formula unit, which has a really rude abbreviation. I am sorry about that, but you know, what can we do? Ionic compounds do not consist of molecules because they go on and on indefinitely in a 3D ionic, what's the word? Crystal lattice. Now, it's really hard to draw a crystal lattice when the ratio is not 1-to-1 between the ions. So I'm not even going to try. What I'm going to do is I'm going to take a look at calcium phosphate. Calcium is 2+, phosphate is 3-, so we need to have 3 calciums and 2 phosphorus. So what we have is we have 3 calciums, 1, 2, 3, and 2 phosphorus, 1, 2. Okay, that is a formula unit of Ca3PO4 2. Here's a relatively easy question. How many calcium ions are there in one formula unit of calcium phosphate? How many calcium ions in one of these? 3. And you don't have to draw it all out like that. You can see from the formula that the answer is 3. There's 3 Ca2+. Let's write this as a conversion factor. We have 3, whoopsie, 3, I keep writing C instead of 3, what is wrong with my brain? 3 Ca2+ for every 1 Ca3PO4 2. I should have made my line longer there. Now, you can, if you wish, write the word ions here because Ca2+ is an ion, and you can, if you wish, write Ca3PO42 formula units. But it's a little bit optional, right? Because it's implied that Ca2+ is an ion because you've written a charge on it, yes? So let's say we have 16 formula units of Ca3PO4. How many calcium ions do we have? So we're starting with our unknown, the calcium 2+ ions. Tell your partner, what do we write next? What do we write next? Tell your partner. I've not heard a lot of talking between you and your partner. Okay, so we're going to take our initial quantities, 16 formula units of Ca3PO4 brackets 2. And what do we write next? What symbol? We write a time sign. You guys are thinking too hard. Just want a time sign. And what do we draw next? A line. Oh, and what goes on the bottom underneath the line? formula units of Ca3PO4 2. Okay. And on the top, tell your partner what goes on the top. What goes on the top? Calcium ions, Ca2 plus ions. Do we know a conversion factor between calcium ions and formula units? Yes, we do. And you don't even have to write it out ahead of time. You can just look at it and say, I know that there are 3 calcium ions in 1 formula unit. By the way, what is this conversion factor called? This is a particle ratio. This time our particles are ions and formula units rather than atoms and molecules, but they're still particles to particles. Okay? And we do that and we get 16 times 3, which I think is 48. Of course. Yeah, it's 48 Ca2 plus ions. How many phosphate ions are in 1 formula unit of Ca3PO42? How many phosphate ions in Ca3PO42? 2. Shocking. Okay, 2. Write it as a conversion factor. There are, what can we put on the top? 2 PO4, 3 minus, and what can we add on the end if we like? Ions, but it's up to you. If you don't want to write it, it's okay. And what do we write on the bottom? 1 what? Ca3 PO4 2, and if you want to, you can write formula units. If you have 18 phosphate ions, how many formula units of Ca3PO4 can you make? Show your work using the conversion factor. Try it.
Wait, that's fast. I'll walk you that. I'll put MC. I see you. Wait, if I walk is at
Our walk is at 11:04.
wait, that means class is like, oh, lunch is 2 hours away. That's crazy.
I know, right? I know.
Outrageous, outrageous. Oh my gosh. So I will add for the calcium.
Okay. And then how many formulas in this for what's the ratio between PO4s?
And usually you say one of the whole thing. One of these, one of the whole thing. One of those. And then yes. Yeah. Yeah, but you did it wrong. Like, because the teachers might have been one. And you're gonna feel for. So. Fix that. Yes.
18
This is why I love it so much.
Okay, so you start with 18. Is that your phone or your calculator, Anthony? Good. Okay. So you're going to write 18 PO4 3 minus, and then you're going to write what next, Anthony? Times. And then PO4 on the bottom, yep. And what on the top? Ca3, PO4 on the top. And if you find like writing formula units and ions just makes it messy and confusing for you, you can just do it just with the formulas, right? Like if it's too confusing to have all that extra stuff in there. Okay, so what you can do then is you can just look at your formula, which I have written incorrectly because I forgot my little 2 there. And you just go to your formula and you say, I have one of the compound. You're always going to go with one of the compound. And then within one of those, how many PO4s do we have? 2. Excellent. All right, so that's going to be 9 formula units. What is the conversion factor between Ca2 ions and PO4 3 minus ions? Ca2 plus and PO4 3 minus. Ca3, PO4, 2. And you just need to look at the formula, right? You say, how many calciums do I have? 3 calciums. And every time I have 3 calciums, how many phosphates do I have? 2, right? 2 PO4s. And if we go back and we look, we say every time I have 1, 2, 3 calciums, I have 1, 2 phosphates. How many PO4 3 minus would it take to react completely with 6 Ca2 plus ions to form calcium phosphate? Uh-oh. I'm doing it wrong. What should go on the top and what should go on the bottom? Usually easiest to go, what should go on the bottom? Start with that. Calcium, yeah. What are we trying to find? PO4. And remember, you take your Ca3, so there's 3 calciums, and then we have PO4 with a 2, so there's 2 phosphates, and so we have 12 divided by 3 is 4? PO4, 3 minus. Okay, so like I said, if you're finding writing the ions and the formula units and the OVs making it messy and confusing for you, just get rid of those words and just use the formulas, okay? Now, honestly, I don't think we need to do this here, I'm guessing. I'll do 1 or 2 of them, but I want to give you the homework first. So your homework, because we have 10 minutes left, but I want to give you your homework first, is pages, because apparently nobody heard what the homework was last day. It's pages 4 through 8. I'm lying, some of you did. Just ignore me. If you did your homework, you're good. Pages 4 through 8. Page 13. And pages 18 and 19. Okay, that is your homework. Make sure you know it. Make sure you do it. I might just check it on Monday. Yes? Because, and there's videos and there's sheets to fill things in. And if you have not filled it in, I will be very sad. And it will cause me like a stabbing pain through my heart. It will be so sad, and nobody wants that. Well, maybe you do. Maybe you hate me, and you really were like, Miss Spence, I just want to cause you a stabbing pain through your heart. Don't do it. I beg of you. Okay? At any rate, now that I've been dramatic, just because you have a formula unit doesn't mean you can't look at individual atoms. Okay? Could you find a conversion factor between Ca3PO4 and atoms of O? Anthony, what is the conversion factor between atoms of O and Ca3PO4? This is on page 17. Is it? Why not? Because there's a 2. So what does it have to be? 8. Yes, very good. Okay. Sometimes just seeing it big and loud in front of you is all it takes. All right. Nathan, what's the conversion factor between atoms of P and calcium phosphates? Nathan? How many phosphorus atoms? This 4 applies only to the oxygen, okay? So inside the brackets, we've got a 4 for the O and no 4 for the P. So this is just going to be how many? 2. 2 phosphorus for 1 Ca3PO4, 2. Now, formula units of Ca3PO4, 2 and total atoms. Azine, how many total atoms? Pardon me? 13. So we have 8 plus 2 is 10 plus 3 is there's 13 atoms per 1 Ca3PO4 2. And we might as well solve 1 or 2 of these. Do you guys think you could solve A and B before the class is over? Try and solve A and B before the class is over. And if you're really good, you might try C and D as well.
No, I can do it. But we do science. This is nice. It's not that long, I'm sure it's very box. They had to maybe change the rate from the normal one because there's construction. Anyway, I'm just gonna follow them right now. It's lunch afterwards. I would think so. I mean, I don't know.
I mean,
I'm sort of like a, you make your own destiny kind of thing, so like, I'm good with whatever you, yeah. You can leave your bag here, I will lock the room, just so like, it'll be safe, you leave everything behind. Having stolen.
I'm just going to slide it back up to the homework again, just in case you missed it.
All good. And I'm just gonna run to the bathroom real quick because I gotta pee before we walk, otherwise I'll be doing the dance the whole way.
oh, he's sliding.
Yes, you can go to the walk.
I'm not only gonna walk there. I'm like my life. Oh, that's fine. Hell no. Gonna be very wrong. Yo, so
Good morning, Burnaby Mountain. We are now going to start calling classes out to head out for the walk, floor by floor. Just a reminder that this walk is intended to be a time to reflect on what you know and what you have learned this week about this human rights crisis. We would now like to ask the first four classes
Wait until we're called.
to head out in front of the school.
Excuse me.